Hey everyone, and welcome back to the Hybrid Friends. Today with me is the amazing Paola from my team at Fast Track. So as you know, I work for Microsoft within the Fast Track team, and Paola is one of our managers with a big passion. So Paola, maybe you can tell the community, the audience, a bit about you and a bit about your passion.
Sure. Thank you for having me, Flo. First thing, good day, everyone. My name is Paola. I am an engineering manager in the Fast Track for Azure organization, and I am also a speaker for the Green Software Foundation. So there you go. My passion is green software and how we can make our applications, especially those in the clouds, because my second passion then is Azure, to make those applications sustainable and efficient as much as possible.
Okay, so sustainability and green IT more or less is our topic for today. And so not many people understand the sustainability. So most people have zero carbon in mind when we talk about sustainability, but I think it's more like having a zero carbon data center. So can you give us a bit more insight of what sustainability and green IT means?
Yes. Yes, of course. So first of all, a couple of information on how we use some naming convention. When we say carbon emissions, what we really mean is CO2 equivalent emissions. So because every gas is polluting in a different way. And emits carbon in a different way. So what we do is we equalize and normalize everything to carbon emissions. So when we say 1 ton of methane, for example, that equals to X tons of carbon, we are already doing this equation. So when we talk about carbon, what we really mean is all type of emissions, of GHG emissions. Then I always heard customers or companies coming to us saying, hey, you have a green data center with zero carbon data center, or you have the best possible sustainable solution. So I'm putting my stuff in that data center. I don't need to do anything else, right? I can just forget about it. And here's the point. The answer is no, you cannot, because one thing is if you run one legacy or badly deployed application in a number of resources in the cloud, but with the same resources, you could run 10 cloud native, cool, fully engineered and efficient applications. So the fact that these resources are compensated or they have low carbon emissions doesn't mean that you have to waste those resources. That's the real point. So we're going to target applications in a sustainable way, making the best use of those resources so that you know your efficiency is intrinsic in the application and does not rely only on the infrastructure where you put the application on.
So that's one thing I learned while I was preparing for our interviews. It's even coming down to what programming language you use and how you build your applications. If you have an inefficient programming language like, let's say, C++ or something, which needs a lot of CPU cycles to run, or you have code which is running or which is or a SQL query or something which is pulling a lot of data, running a lot of CPU cycles, it's more or less then wasting resources, wasting energy, which can be then with a better programming language, with better and optimized code, as you said, could run 10 times faster and then free up other resources for other operations, for other software. Is that estimation, that learning correct, or is there more to this?
There is a bit more to this, but this is definitely a starting point because, of course, choosing the programming language is not something that one can change. When I have a bunch of developers working in my company, it's not that I can tell, hey guys, tomorrow we're going to learn Go. Forget about C++. That is impossible, nearly impossible to do. But it's true that some of the choices we make, not just in the programming language, but in the stacks we choose, in the architecture, in how the application is developed and coded, for example, the data that is exchanged, the bandwidth, the networking side, everything has an impact on the energy that is consumed. So originally, developers never had to deal about this stuff. The only developers who had to deal with energy consumption are typically mobile developers. Why? Because they care about the battery use. They don't want the phone to die on your application. So they need to somehow be careful on the usage of power resources. Now, if we try to move those guidelines into the server and backend and front end application world that is not typically mobile, we never had to deal with this stuff. We just, did our application, and once I think that the user has a device plugged in, I don't care how much it's consuming. What we're saying now is we have to be aware. Not only we want to be aware of how much my application is consuming in terms of energy, but ideally, I want the application itself to be aware. This is a concept that we've introduced in the Green Software Foundation of carbon awareness, and it's a way for the application to know that the energy that it's using in the location where the servers, the backend or the front end, or even the device is running, has a concept of carbon intensity. So is the energy that I'm using a clean one? Does it have a carbon intensity that is super low because it's maybe coming out of renewable sources? It's solar, it's wind, it's geothermic, whatsoever. If so, then I would love my application to be able to do more. And I can do more because I'm using clean energy. On the other hand, if right now in that location I see that the carbon intensity is higher, that means that the electricity is produced probably burning fossil fuels, gas, or even coal in some cases. And so what I would like to do is for my application to recognize this and somehow scale down. I know this sounds not so easy to do, but there are ways of doing this. Scale down or reduce the number of features or reduce the number of nodes or lower the tier of a resource in the cloud. There are many ways of doing that, and even involving the customer saying, hey, I'm giving you less performance on this application because right now this application is contributing to a cleaner air. Would you like to wait a couple of seconds more for your application to run? And me, I would say yes. I mean, I'm from the 90s, so a couple of seconds more don't matter a lot to me. It doesn't have to be millisecond, latency to run an application or to run a command. I can wait. And especially I can wait if this is for a good cause because it will give me cleaner air.
Yeah, but it's for example, it's something we're doing since I think I worked on building a wheat mile together with some colleagues 15, 16 years ago, and it was connected to a fabric where they used the clean and powder and to produce. And if there were times where we had a lower production in a fabric for the end product, they were just sending a signal through our wheat mile saying, hey, don't produce too much, just reduce your production rate. And with that, there was a signal sent to the silos saying, okay, guys, we don't need, you can just fill up to 90%, but then don't order any additional wheat from our suppliers because the fabric is we are not producing or the fabric is not taking enough for the mile, so that we would overrun our silos at the other end. And it's the concept is still there. It works. It's just electrical signals you could leverage. Let's say you have a power generator which sends a few signals, says, hey, I'm now on electricity from sun, from wind. Please, lovely application, use as much as you prefer. And then during night hours, when we need to switch to coal, when we need to switch to oil-produced energy, where we do not have those renewable energies, hey, during night hours, just reduce your footprint, go into sleep, or just let people wait a few cycles more until we have the sun is back and then we have enough wind to produce renewables. I really like this content, and at least from an IoT or technical point of view, those signals are there. It just need to be programmed, and they need to, let's say, be an API you can touch with your application.
Yes, and I would like to show you a website just to visualize this concept. This is what we were talking about. This is one of the API providers that we use for the carbon-aware SDK. By the way, the carbon-aware SDK is one of the first open source projects from the Green Software Foundation. You can find it on GitHub. I will, with Flo, will give you the link to go and search it. So it's open for everyone to work and play with it. And it relies on a few APIs that are public and that they offer exactly this kind of information, that you go to a region and in real time you can get the emissions and the carbon intensity of that region. You see the carbon intensity right now for Germany is 345 grams of carbon. And this is how it's built. You have wind energy, you have coal, so probably solar is low because it's winter, it starts to be winter, it's cold, you have less sun, and so you have to burn coal and maybe gas, you see here, to produce your energy. This might change throughout the day. Actually, this will change throughout the days, and same is for northern Italy. I always envy our cousins in France who have nuclear energy, and so everything is clean. The air is super clean because everything to burn like coal or any other fuel. But the point is, this information is available, it's public, and it's available through an API to your application through the carbon-aware SDK. So your application can get this signal, as you were mentioning in your example of the mill and the factory, and then decide what your application can get rid of. Because right now, if I see that in Poland, I have a very color convention is also very very immediate, so you can see where the things are not going so well. So if I have my application running here and I see that the application intensity is super high, so it's crazy high, they're burning coal, a lot of it, so they're polluting the air and producing a lot of emissions. So what do I do? What can I do? My part in here would be deciding that my application, for example, could have an eco mode, a minimum viable number of features and things that are that my user perceive as the minimum. I have to get this, but everything else is maybe not urgent and not immediate. So I will push this eco mode version and say, I will do less when the carbon intensity is that high. I will do the minimum. Once it gets, lower to a nicer shade of yellow, then I can say, okay, now I'm going to add more features. I'm going to add more stuff to it because I can see that I'm clean energy.
You could also use that for load balancing mechanisms. So as you know, I'm also from the networking side, so I could train a load balancer with that to distribute my load. So
You can.
only say, okay, now maybe Poland is pretty central, but then I could train my load balancer and say, okay, only fees you be able or be used for people coming from geolocation Poland, but everyone else who is in the Nordics, who is maybe in a certain range of milliseconds, can then be sent to Sweden, Norway, France, so where we have more or less a greener footprint. So not doing load balancing on a way like we do it right now, nearest location or something like that, but maybe do it from a sustainability, from an eco position, and say, okay, my users would still be fine with 20 milliseconds entry time, so I can send them to Norway where I have much better efficiency.
So you described two of the main techniques that are used to do this, which are demand shaping and demand shifting. So the demand shifting is I'm trying to push my workloads somewhere else in time or space. So it could be, as you say, I'm pushing them to Denmark because it's greener. That is an option. That is demand shifting in space. But I can also do it in time. I can say, hey, this workload, I'm going to run it tonight because then it will be better for my carbon intensity. And so I will just postpone it because it's not urgent, and I will run it later on when I know that my carbon intensity is decent and then I am not polluting. The
Or
second technique.
I think it's more than the day, because when you can use sunlight,
It depends.
instead. Yeah,
As,
it depends on the region, but I
yeah,
think most likely in the more equator near regions, I think it would be more morning, daytime hours because of the high intensity of the sun.
possibly, but there are regions that rely almost exclusively on, for example, geothermic or
Mm.
wind power. So in that case, maybe in the night you have more wind. It really, this is a good point, but it really depends on the region you are targeting and what are how the energy is produced in that region. And you see, it's different from country to country. There is
Yeah.
no country equal to the other. This is um, out of political decisions and choices of the countries. So we're not, this is
It is
how it
mostly also a historical reason. So, for example, in the Emirates, you have cheap oil. So it's for them it's more efficient to still produce energy on oil or gas because it's there, and to
yeah,
build those or not solar parks, and it's just more cost intense. While our friends from the Nordics always had wind. They have strong winds, so they were pretty good with wave water generated,
you see,
uh, yeah, hydro,
Sweden
and
is hydro power.
yeah,
So yeah, you're right. This is exactly how it is. You know that every country is different, has a different set of how the energy is produced. We don't have all the details, but we don't have to, because there are these APIs that do the job for us and will give us a number, and with the number, developers can do anything, once
correct.
you that number. But back to the techniques, the second one is demand shaping, and demand shaping is also a very popular technique for cost reduction. Imagine that you are running a PaaS service on cloud, and suddenly your carbon intensity is higher, and you decide that you want to play it more sustainable. So what you do is you downsize the tier of that PaaS service. You bring it to a lower size, or reduce the performance, or reduce the number of nodes. You shape the service according to the demand of the energy production. That's the demand shaping. And it's super useful because, for example, we have seen customers use it as a cost saving technique, because when you don't need, so you have this service and you keep it 24/7 switched on, but do you really need the same performance for the whole duration? You don't, because there are spikes and peaks and then lows. So when there are lows, you just shape the service to just service the lower peaks, and that is the cost reduction on one hand. So it's typically a good reason to do that. But the second good reason is carbon
Yeah,
reduction, which is even better.
yeah. And are there examples, let's say from Azure out there, or some kind of code which can already be repurposed, or examples in any documentation where you can read through how others build it?
Yes, there are samples. I think one was built from one of the engineers in Fast Track on how to consume the carbon-aware SDK. So there are samples out there. The GitHub repo is open to everyone. It is an open source project. So the Green Software Foundation is part of the Linux Foundation. So we want everything to be open source, because we need right now for everyone to contribute and to give a bump to this logic of green software, because we're just at the beginning. This started a couple of years ago, and we want to have more traction, basically.
So that's so I think we had covered a lot, so we don't want to overwhelm. So there's still the option to have another meeting on that, but it's amazing what you do with the Green Software Foundation, what you do with the team, and what we already have as a starting point. It's just now, I think, a point of making people aware and get them to use it.
Yes, making people aware that there is such a thing as saving energy from the application's point of view. That's the first awareness that we need to push to developers, and then making sure that customers and companies doing cloud but even in on-prem data center, this applies pretty much everywhere, that they don't waste resources. They don't waste resources and energy. We haven't talked about embodied carbon. I'll talk about this in our next conversation, but do not waste resources. The first goal of everyone. It should be the first goal of everyone, even in IT. That's the message.
And that's one thing. There's a term in Germany when it comes to governmental costs. It's the EDA cost. So costs which we have anyway.
Yes.
Electricity and so on. So we don't care about that. Yes, even if it's there, if it's paid by taxpayers or your company, think of those. Even if they're there, it does not help us as a humanity kind of thing if we waste those resources because we have them.
Yes.
So I have now one child of my own and 3 social kids. I want to have them to have a world they can live in and where I can have my grandchildren then.
Yes. Hopefully. I'm grandchildren. I see this very far in the future, but it could happen. Yes, no, definitely. That's the message, that we don't want to waste resources of any kind. So again, cloud is good because resources are shared. It's like when you think of taking public transportation rather than your own car, but it doesn't mean that you can waste those resources. You still have to use them in an accurate way.
That's really the point. It's again like with the public transportation. It can be, if in some regions maybe not efficient, but you can make it that way. You can think of your route through Berlin or through Lisbon or through France and make it efficient for you. And that's with that public cloud approach with the Green IT Foundation. It's help us with your thoughts, with your experience to make it efficient. Use the tool sets you have here.
Yes. Perfect.
Thank you so much for the talk, Paola. We should definitely have another one, maybe someone early next year, with our full schedule with Ignite coming up, and then also Christmas and all those blocking stuff for technology. It was very interesting also for me, as I'm not deeply in that topic. I said I did some research in the beginning before our interview, but yeah, great to have you to have the talk with you, and hopefully having you again on the channel.
Thanks for having me. And if there's any question, my LinkedIn profile is pretty much all about green software, so you can reach out to me anyway.
Perfect. And for everyone else, subscribe to the channel, leave us comments, leave us ideas, open a discussion with Paola if you like. And yep, that's all for today and for now. Bye.
Bye-bye.